this video, you will get to see SPM in action. I will use the example from the introductory video with 6 therapeutic areas and 4 phases, clinical and regulatory. I will show how to create a pipeline model for this specific example by creating custom phases and custom streams. In this example, the streams will represent therapeutic areas, but in general, they can represent anything you want, such as different development paradigms or deal-making strategies that coexist in your portfolio. Using this model, we will run simulations to answer the first question we posed in the introductory video, namely, how will the number of launches fluctuate over time? At the end, we will save our work to a file. Let's get started. When starting SPM, it is pre-populated with the default pipeline structure, which we can see by choosing from the Edit menu Development Phases. Specifically, we see a typical drug development pipeline defined in some amount of detail, including both preclinical, clinical, and regulatory phases. This can be customized to the specifics of your company and the study you want to perform by adding phases, changing the order of phases, editing the description of existing phases, and removing phases. We also need to specify which phase is associated with each of several events, such as issuing patent or generation of child assets, such as new indication or line extension. For this tutorial, I have already performed offline the necessary add-remove operations to create the pipeline from the example slide and save this to a file, which I will now load using the File Load menu. We can check the phases, and indeed we see phase 1, 2, 3, and regulatory. In this scenario, I have also defined streams corresponding to therapeutic areas. We can see them under Streams, Internal Streams. Let us enlarge this section of the SPM window. Just like phases, streams can be added, they can be copied and pasted, they can be moved up or down, they can be renamed, and they can be removed. I have set up each of these streams to push 2 assets into the first phase of the pipeline each year. I have also customized each stream with information about what it takes to develop an asset from that stream. We can see this on the Productivity tab, where data is entered on a per phase basis. Each phase is represented by a column. We need to provide information about the direct cost in millions, about the cycle time in days, and about the probability of success in percentages. We can express our uncertainty about these properties by entering triangular distributions defined via their mean, mode, and max values. For instance, the direct cost for phase 3 for oncology assets is somewhere between 70 and 80 million, most likely around 75 million. Whenever an asset is created from this stream, a sample is drawn from this triangular distribution and assigned as the cost of the asset for phase 3. Similarly for the other phases and properties. All of these values are editable, and if we do not wish to model uncertainty, we simply check this box, as I already have, and the mode value will be used deterministically for each asset. We want to put this number back to 75 because we're trying to model the example from the Excel file, and I have copied all of these mode values from that file and pasted them into SVM. You can use Ctrl-C, Ctrl-V to copy and paste single cells or entire blocks of cells. To select the area you want to copy, use the arrow keys while pressing the Shift key. I have also entered on the Archetype tab information about what would happen if an asset from this stream would make it to the market. Specifically, we enter the probability of the market size being small, medium, or large, the revenues associated with each market size, in the form of peak year sales distributions, and costs that the asset may incur once it is on the market, such as cost of products sold or sales and marketing expenses. We are almost ready to run our first simulation. Just a couple more things I want to point out. On the Executive tab, we set how long the simulation should run, typically in years. We also specify what our initial portfolio is at the start of the simulation. For this demo, I will start from an empty portfolio, but for real-world studies, you will want to load the initial portfolio from an Excel file listing the actual assets that you have in your portfolio today and their properties. I have also set an initial budget that is large enough to work on all assets entering our pipeline. You can change this later to a more realistic value. Finally, since the simulation is stochastic in nature, on the Simulation tab, we can specify how many trials, that is, how many Monte Carlo runs to do, and the random seed. Let's just do one for now and click the Run Simulation button. Two reports pop up. They are the ones that were checked on the Reports tab. The first one is a yearly launches report. For each of the 30 years that the simulation ran for, the height of the respective red bar represents the number of assets that launched that year. We can see that for the first few years we had no launches. Not surprising, since we started with an empty portfolio. After a few years, we start to get launches at a rate of anywhere between 1 and 5. The second report also shows launches, but instead of breaking them down by year, it counts all launches over the 30 years, about 68 in this case. As I mentioned, the simulation is stochastic, so let's run again with a different seed. We see that this time we got an even larger swing, 2 years in a row with no launches, followed later by a year with as much as 6 launches. Let's now tell the tool to automatically run the simulation for 20 different seeds. The progress bar shows us how many seeds have been done so far, and the plots get updated automatically unless we check the batch mode box, which suspends updates until the very end and will speed things up. The height of the bars in the top plot now represents the average number of launches in each year, with the average taken over the 20 different runs. The whiskers are 95% confidence intervals for this average, an indication of how much fluctuation there is from one run to the next. We can see, however, that the average fluctuates a lot less from year to year. It is therefore important to look both at averages and at individual runs of the simulation to educate yourself on what is normal pipeline behavior. Time to save our work. Go to the File menu and click Save. Enter a name for the file and click Save again. In the next tutorial, we will learn more about what other kinds of reports we can make and how to make and customize them.